Right now, tonight, fragments of an unknown asteroid are burning through Earth's atmosphere. Not predicted, not tracked, not announced, just arriving. And the part that has planetary scientists genuinely alarmed isn't the debris, it's that after months of searching, nobody can find where it's coming from. There's something else buried in this story, a detail that connects this invisible asteroid to one of the most beloved spectacles in the night sky, a connection that changes everything we thought we understood about the meteor showers we've been watching our entire lives. We'll get there. But first, you need to understand what actually happened. March 2026, automated sky cameras in Ohio recorded a fireball detonating in the upper atmosphere. A 7-ton space rock, moving faster than a rifle bullet, vaporized in a flash bright enough to cast shadows at night. Residents reported sonic booms rattling windows across the Cleveland area. That same week, similar reports came in from Texas, then New York, then Turkey, then Australia. 4 continents, same window of time. People filmed it, posted it, asked the same question on every platform. What is happening up there? The answer came from a researcher named Patrick Shober at NASA's Johnson Space Center. Shober had spent years doing something most scientists don't have the patience for. He wasn't pointing telescopes at the sky. He was going backward, through millions of individual meteor records collected by automated all-sky camera networks in Canada, Japan, California, and Europe. Hundreds of cameras, millions of recorded events, most of it noise. The same predictable showers from the same known sources year after year, but embedded in that data, Shober found something that had no business being there. A cluster of 282 meteors following an orbital path nobody had ever documented, not from any known comet, not from any cataloged asteroid. A completely new debris stream hitting Earth's atmosphere on a repeating annual schedule, arriving every spring between mid-March and early April. He named it M2026A1, and the orbital mechanics told him exactly what kind of object created it. The parent asteroid, still unlocated, travels on an extreme orbit that brings it nearly 5 times closer to the Sun than Earth's distance. Picture the distance between Earth and the Sun. Now cut that to 1/5. At that range, surface temperatures on a rocky body can reach several thousand degrees. The rock doesn't just heat up, it fractures. Surface minerals expand and crack. Trapped gases that have been frozen inside for billions of years suddenly have a path out. They vent into space, carrying dust and fragments with them. Chunks shear off the surface and scatter through the inner solar system along the asteroid's orbital path. And every year when Earth crosses that path, we fly through the wreckage. Scientists have a name for this: a Rock-Comet. An asteroid that behaves like a comet, shedding a tail of material, but is made of solid rock instead of ice. Before this discovery, exactly 1 confirmed Rock-Comet debris stream existed in the entire scientific record. 1, its name is Phaethon. And what Phaethon produces every December, when Earth crosses its debris trail, is the Geminid meteor shower, up to 150 shooting stars per hour. One of the most spectacular annual events in the night sky. Phaethon is 3.5 miles wide, and for decades astronomers have watched it shed material without being fully able to explain the mechanism. Shober's discovery just confirmed that mechanism is real, and that it's producing a second, previously undetected debris field hitting our atmosphere right now. That was the first holy shit moment. Here comes the second one. Shober didn't find this asteroid by seeing it. He found it by analyzing what it left inside our atmosphere. The parent object itself is completely invisible to every optical telescope currently in operation on Earth. It doesn't reflect enough sunlight to trigger detection systems. It approaches from the direction of the sun, which places it in a blind spot that ground-based observatories are physically incapable of covering. Think about what that actually means for planetary defense. NASA currently tracks over 41,000 near-Earth asteroids. That number represents years of work and billions of dollars of telescope infrastructure pointed at the sky. But every single one of those detections depends on reflected sunlight. Objects that approach from the sun's direction, or that are simply too dark to reflect adequately, are invisible to the entire system. And we just confirmed that category of object is real. Not theoretical, real. Shedding debris, hitting our atmosphere annually. And we only know it exists because its wreckage started landing on 4 continents. Here's what scientists don't yet know: how large the source actually is. The fragments Shober analyzed in the atmosphere are sand and gravel, small, but they came off something larger, something still out there, still following that extreme orbit, still losing material with every pass around the sun. The debris stream Earth crosses each spring is not static, it grows with each orbit, which raises a question nobody can currently answer. What is the remaining mass of the object producing it? And here is where this story connects to something much more personal. Tomorrow night, if skies are clear where you are, go outside after midnight and look up. You'll see the Lyrid meteor shower near its peak. Streaks of light, perhaps a dozen per hour, some of them bright enough to cast a brief shadow. They're beautiful. They've been recorded for over 2,600 years, making them the oldest documented meteor shower in human history. And they come from Comet Thatcher, a known source, tracked, cataloged, understood. Every meteor shower you've ever watched is debris, the remnants of something that passed through the inner solar system and left pieces of itself scattered along an orbital path. Perseids from Comet Swift-Tuttle, Leonids from Comet Tempel-Tuttle, Geminids from Phaethon. These are the named ones, the mapped ones. M2026A1 is what the unmapped ones look like. It arrived in our data not through a telescope, but through the sky above Ohio. Not as a discovery in a scientific journal, but as a fireball rattling car alarms at 2 a.m. The cameras that caught it weren't built for planetary defense, they were built to study meteors. And it was only because one researcher had the patience to search through millions of records that we know a new debris stream even exists. Which brings us to the most important number in this story: 2027. That's when NASA's NEO-Surveyor Space Telescope is scheduled to launch. Unlike ground-based observatories, it doesn't rely on reflected sunlight. It detects the infrared heat signatures of asteroids directly, which means it can see dark objects, sun-approaching objects, and objects in orbital zones that are currently invisible to every detection system we have. NEO-Surveyor was designed specifically to close the blind spot that M2026A1 just proved is real. Construction is complete. The mission survived near cancellation. The launch window is 2027. Until then, the source of this debris stream remains unlocated. It continues its extreme orbit. It continues to shed material, and Earth continues to fly through the resulting debris field every spring, as it apparently has been doing for long enough to build a stream of 282 detectable meteors, a number that represents only the fraction large enough to register on camera networks. Remember at the beginning when the missing source was the detail that mattered? Here is the full weight of that. This is only the second confirmed rock-comet debris stream in recorded scientific history, which means this entire category, sun approaching, dark, actively fragmenting, invisible to current systems, was essentially unknown to planetary science until now. We found one. The data gives us no reason to believe there is only one. The debris streams we know about have names: Perseids, Geminids, Leonids. They appear on every astronomy calendar. Parents identified, orbits mapped, predictions reliable to within minutes. The M2026A1 has a designation, it does not yet have a parent. Tonight, if you watch a Lyrid streak across the sky, you're watching a piece of a comet that last came through the inner solar system in 1861. You're watching ancient material from a known object behaving exactly as predicted. That's the mapped universe, the one we've spent centuries learning to read. What Shober found is a reminder that the unmapped version is still out there, still arriving on its own schedule, still leaving evidence in the sky above Ohio and Texas and Turkey and Australia. Evidence that we almost missed entirely. Here is what we want to know from you. The fireball reports that helped confirm this discovery came from ordinary people who stepped outside and looked up. If you saw something unusual in the sky this past March or April, a bright streak, a sonic boom, a flash that didn't match anything expected, drop your location in the comments. The research team is still actively building the data set, and public observations have directly shaped this work. The universe has been sending us signals about this object for years. The only reason we're talking about it now is because someone, finally, was patient enough to listen. What else are we missing?